Tack så mycket. Yes, I would like to present you our research on making smart materials for energy applications from ionic liquids. And you might have wondered, what are ionic liquids? Well, you probably have used something like this morning. Ionic liquids are nothing else than salt. So this is a table salt crystal, rock salt, that you use for probably in the morning for your egg to make it a little more tasty. Its structure, and it's really a rock salt, is made of positively charged cations and anions, and they electrostatically attract each other, and that's why this salt is solid. The advantage of a salt are you can't smell them. You know that. You sniff, you don't smell anything. And you can't burn them. You really can put fire on salt and it won't burn. And that are the true advantages of salts. And we are using such salts as solvents to make materials for energy applications. But when you think of a solvent, you think of water, you think of ethanol. So we have to turn those salts liquid to make ionic liquids, to really turn this hard material into something that is a liquid. And you can do that by starting from rock salt, and you take out the sodium cation, Na+, and you replace it by a really large, floppy, organic cation. So you see, this is a lot larger, and you have to imagine that you replace each of the silvery points here by this. So you're moving the cations and anions farther apart because this is really big. So the attraction goes down, and the whole thing no longer can stay solid, but has to become a liquid. And one can indeed make those materials by combining two solids, so one white solid, with another one, and both solids are actually approved as food additives, and you find them also in cosmetics. And when you just heat them quickly, and I hope that works, that's always the fate of a chemist. You try to make experiments and then they don't work. I guess physicists sometimes share the same fate. I guess it's hard to see, but you see that the two components already combine. And that you get a liquid. The amazing thing is that this liquid really stays liquid at room temperature. And to melt table salt, you would need more than 800 degrees centigrade, so that would be extremely hot. Still, you can't smell them, you can burn them, and that is why people consider them as alternative green, environmentally benign solvents. The true joy for a chemist is you have always those two components that you put together, and the chemist can imagine a sheer endless number of different combinations. So you can tailor your liquid salt for a given application. And we want to contribute with our research to sustainable chemistry. So we are looking at improving systems that contribute to energy efficiency. And just think of a car as a model. What can we improve there and turn it into a really nice, fancy, modern green car? Well, it would be nice to have a carbon-free fuel, for example, hydrogen, and we can use those salts to make better catalysts for water splitting. So you turn water into hydrogen and can use that in your car as a green fuel. We also work on thermoelectrics that can convert the heat from the exhaust, which is wasted, it goes into the surrounding, but recover that and turn that into electricity that could be used to drive the car electronics. And lastly, we're working on developing light-emitting electrochemical cells, so that are lighting components that are based on these salts that are very energy efficient and can be used for signaling, illumination, or displays in your car. So altogether, we hope that by playing around with these salts, we manage to really contribute to a better sustainable science as a chemist. Thank you.
Thank you.